this module, you will learn about the structural representations of organic compounds. A chemical formula which represents the arrangement of atoms in a molecule is called the structural formula of a molecule. The various structures of organic compounds can be represented by 4 different ways. They are Lewis structural formula or dot structural formula, dashed structural formula, condensed structural formula, and bond line structural formula. Let's first look at the Lewis structural formula. The Lewis structure is named after the scientist Gilbert N. Lewis. In Lewis dot structure, a pair of electrons forming a covalent bond is represented by using a dot or cross. However, the Lewis dot structure can be further simplified by representing a pair of electrons by a dash. This simplified representation is called dash structure. Thus, a pair of electrons forming a single covalent bond is represented by a dash. A double covalent bond is represented by a double dash, and a triple covalent bond is represented by triple dash. Organic compounds containing heteroatoms with lone pair of electrons are represented by a pair of dots on the respective heteroatom. This structure represents the bonding between atoms in a molecule and also shows the presence of lone pairs present on the atoms, if any. This structural formula shows the arrangement of atoms and the type of bonds present between the atoms in the molecule. Here's the dash structural formula for ethane. In ethane, 2 atoms of carbon are attached to each other by a single covalent bond, and all carbon-hydrogen bonds are also single covalent bonds. In ethene, 2 atoms of carbon are connected with a double bond, and 2 hydrogen atoms are attached to each carbon by a single bond. In ethyne, 2 atoms of carbon are connected with a triple bond, and 1 hydrogen atom is attached to each carbon by a single bond. In methanol, carbon is attached to 3 hydrogen atoms and 1 hydroxyl group. 2 lone pairs of electrons present on the oxygen atom of hydroxyl group are represented as shown here. Now, let's look at the condensed structural formula. In a condensed structural formula, some or all the dashes that represent covalent bonds are omitted, and the number of identical groups attached to a carbon atom is represented by a subscript. Thus, a condensed structural formula is an abbreviated form of dash structure. The condensed formula of ethene, ethyne, and methanol are represented as shown here. At times, the formula is further condensed by enclosing the repetitive structural unit within a bracket and placing an integer as a subscript, indicating the number of times the structural unit is repeated. In this case, CH2 is put within brackets and has a subscript of 6, indicating that the structural unit CH2 repeats 6 times. Finally, let's look at the bond line structural formula. A bond line structural formula is a short and simplified method for representing an organic compound. In this method, carbon-to-carbon bond is represented by lines drawn in zigzag fashion. Represent carbon-to-carbon bonds, and line terminals generally represent methyl groups if they don't have a functional group, whereas the line junctions represent the carbon atoms attached to appropriate number of hydrogen atoms required to satisfy the valency of carbon. If any heteroatoms are present in place of hydrogens, they are specifically written by using their symbols as shown here. Let's consider the dash structural formula of 3-methyl octane. Now, let us represent the bond line structural formula for this as shown here. Here is the condensed structural formula and the bond line structure formula for 2-bromobutane. Cyclic compounds are represented by polygons. In a polygon, the corners represent a carbon atom and the sides represent a carbon-carbon bond. Symbol of atoms other than carbon and hydrogen are shown on the structure. Organic molecules can be represented by using the solid and dashed wedge formula. This is a three-dimensional structural representation of an organic compound. This formula can be represented on the paper by using three conventions. That is, a dash, a solid wedge, and a dashed wedge. A dash is used to mean that the bond is in the plane of the paper. A solid wedge means that the bond is projecting out of the paper and is towards the observer. A dashed wedge is used to mean that the bond is projecting out of the paper and is away from the observer. The 3D image for the methane is shown here. Three-dimensional molecular models are used for better visualization and perception of the shapes of organic compounds. There are three types of molecular models: framework model, ball and stick model, and space-filling model. In the framework model, the atoms are not shown. Only the bonds connecting the atoms of a molecule are shown. This model is used to study the patterns of bonds and does not consider the size of the atoms. In the ball and stick model, both bonds and atoms are shown. The balls represent atoms while sticks represent bonds. Compounds containing double bond, as in ethene, are represented in a different way. In place of a stick, a spring is used to represent the double bond. Hence, this type of model is called ball and spring model. Another type of molecular model is space-filling model. The relative size of each atom is based on van der Waals radius. That is, the volume occupied by each atom is shown. Bonds are not shown in this model. You have now reached the end of this module. In this module, you have learnt that a chemical formula which represents the arrangement of atoms in a molecule is called the structural formula of a molecule. Structures of organic compounds can be represented by the following ways: Lewis structural formula or dot structural formula, dashed structural formula, condensed structural formula, and bond line structural formula. In Lewis dot structure, A pair of electrons forming a covalent bond is represented by using a dot or cross. The simplified representation of Lewis dot structure is called dash structure. In this formula, a pair of electrons forming a single covalent bond is represented by a dash. In a condensed structural formula, some or all the dashes that represent covalent bonds are omitted, and the number of identical groups attached to a carbon atom is represented by a subscript.